Okay, this is a parallel circuit, and we are asked to find the total current and the current in each resistor. Now, the rules for parallel circuits applies to this one, and the first rule says that the reciprocal formula can be used to find the total resistance. So we can take that approach. For part A, we'll say that 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Now, there's several ways to do the reciprocal formula. Reed's textbook often uses math that's relatively old for the new calculators that we got these days. And so they will use a common denominator to solve the addition of 1 over 2 plus 1 over 4 plus 1 over 6. Now, we can convert each of these fractions to a decimal, or we can look for a common denominator. We can rewrite the reciprocal formula to put in to our new fancy calculators. And so if we take the approach that we're going to find a common denominator, the least common multiple of 2, 4, and 6 is 12. So that becomes the lowest common denominator for this fraction. Now, 1 over 2 is 1/2 of 12, so that gives us 6 over 12. Plus, 1 over 4 is equal to 1/4 of 12, which is 3. And 1 over 6 is equal to 1/6 of 12, which is 2. So we have 6 over 12 plus 3 over 12 plus 2 over 12, or like I've written it, 6 plus 3 plus 2 over 12. Now, that says that 1 over RT is equal to 11 over 12. Or RT equals the reciprocal of 11 over 12, or 12 over 11. And if we divide 12 by 11 in our calculator, we will come up with 1.09 ohms for RT. Now again, there's more than one way to come up with that value. In the notes on page 16, I have shown you 2 different ways that you could come up with the 1.09 ohms. Okay, now, the part A of the question actually asked us to find the total circuit current. So when we write Ohm's law in terms of current, we have IT is equal to the total voltage applied, or E, divided by RT, which we just calculated. We have 24 volts applied to this circuit, and we'll divide that now by the 1.09 ohms. And if we do the division, we'll come up with 22.0 amps for the total current in the circuit. Now, part B asks us to find the current in each branch resistor. Now, if we look at the circuit, we have 24 volts applied to all 3 of these resistors. So remember that we can apply Ohm's law individually to each branch of the circuit because we know the voltage across it and we know the resistance of the branch. And so because each resistance in a parallel branch or a parallel circuit like this one has the same voltage applied to it, we can say that I1 is equal to V1 over R1. And we know that V1 is equal to E, so we have E over R1. That gives us 24 volts divided by 2 ohms, or 12 amps for I1. Likewise then, if we apply Ohm's law to I2, we have I2 equals V2, or E divided by R2. And so 24 volts divided by 4 ohms gives us 6 amps for I2. Now we also wish to apply Ohm's law to I3, so we have 24 volts divided by 6 ohms, and that gives us 4 amps for I3. Now you'll notice that Kirchhoff's current law tells us that the sum I1 plus I2 plus I3 is equal to the total current in a circuit. So if we add up 12 amps plus 6 amps plus 4 amps, we will come up with 22 amps, which is the total current in the circuit. Now, remember that if we had done part B first and found that the total current in the circuit was 22 amps using Kirchhoff's current law, we could say, and this is a bit of an aside now, for part A, we could have said that if we apply Ohm's law to the circuit, IT equals E divided by RT. And had I found IT first, we could say that RT is equal to E divided by IT. That gives us 24 volts over 22 amps, and you'll find that that gives 1.09 ohms. And so, our idea is that we don't necessarily need to find the total resistance using the reciprocal formula, right? And so we have found that RT can be found from Ohm's law if we found the total current first.